Okay, hello everybody. My name is Amir Bazrgar. I'm a postdoc researcher working with Naresh at the University of Guelph. Very pleased to meet you all here. So I'm going to talk about the biomass crops for soil carbon sequestration in marginal land, and I'm going to have a look on a comparison between the herbaceous and woody cropping systems. Biomass cropping systems have a great opportunity for increasing soil organic carbon and improving the soil health, and at the same time helping growers by producing some valuable feedstock. But there is some challenges achieving the biomass cropping goals. And this challenge is, one of the challenges is the potential competition between the cropping system and agricultural production that have already used agricultural resources for producing food, feed, and fiber. Marginal lands proposed for biomass production could be a partial solution for this by reducing this potential competition. And because of that, recently many researchers and scientists promoted working on cropping systems for carbon sequestration. But there is some research gaps on their studies, and mostly they're examined one woody or herbaceous, not both of them, and also they're working on above ground biomass, and mostly they're working on young system less than 6 years. In this study, we aimed at comparing the long-term carbon sequestration potentials at the system level in 9-year woody and herbaceous biomass cropping system in marginal land in Ontario. For this purpose, we conducted a 2-year experiment at the University of Guelph Research Station in Guelph, Ontario, that it is or it was a hub of the tree-based cropping system, agroforestry system, and biomass cropping systems. The soil classified as a gray-brown loamy soil with a fine sandy loam texture, and classified as a class 3 marginal land based on CLI classification. Agriculture were used for corn, beans, and wheat until 2008, and from 2009, it converted to the biomass research, so planted the poplar, willow, switchgrass, and miscanthus in it. We quantified above ground and below ground biomass carbon in 2017 and 2018 by destructive sampling, and then we quantified above ground and below ground carbon using the high temperature combustion techniques with LICO. And also we quantified soil organic carbon. We sampled in 2017 and 18 at the depths of 0 to 15 and 50 to 30. And then we determined the soil organic carbon using LICO. And then these data were compared with the existing 2009 data as a baseline to quantify the losses or gains from 2009 to 2018. Moving to the results, first we're going to have a look on biomass carbon content. Regarding the above ground biomass, we saw that willow and miscanthus had the highest amount of above ground biomass carbon. Willow had 12.39 megagram carbon per hectare, and miscanthus 10.91. And regarding to comparison between the woody and herbaceous, we saw that the woody cropping system significantly had the higher amount of above ground biomass carbon. It was about 10.02.
Are those annual, or is that like with the 3-year harvest?
No, this is the cycle 3 years harvesting.
Sorry, so is that 3 years of carbon, or that is all annualized? So that would be the 3 years divided into each individual.
No, this is not for the 3 years. This is for the 3 years.
Oh,
yeah, the total. Yeah. And looking at the below-ground biomass carbon, we couldn't see any significant difference between the woody and herbaceous. So for the woody, it was 7.09, and for herbaceous, 7.95. The second part, we had a look on the carbon stock allocation in the different plant components. So in this part, we saw that poplar have a great storage in the above ground biomass carbon, the highest amount among all the other crops. It was about 65% of carbon allocated in above ground. And the highest amount of allocation in the leaves was were seen in the willow. It was about 7% allocation to the leaves. And switchgrass had the highest amount of allocation of carbon in the below ground biomass. It was about 66%. The next part is comparison of soil organic carbon sequestration in different crops. So what we can see is woody crops and switchgrass were able to increase soil organic carbon significantly in the 9-year period from 2009 and 2018. But miscanthus failed to reach the significance. However, the amount of soil organic carbon in 2018 were similar without any significant difference in all the crops. Comparing the herbaceous and woody crops, we couldn't see any difference between soil organic carbon in 2018 between the woody and herbaceous. In woody, it was 80, and in herbaceous, 74 something. And also, the annual, the soil organic carbon gain in 9 years was also similar in the woody and herbaceous. It was 11 in woody and something like 10, close to 10 in herbaceous. Then we quantified the total carbon pool in biomass crops using this equation. So we added soil organic carbon to above ground biomass carbon and below ground biomass carbon. And we can see that the total carbon pool was significantly higher in willow compared to the other biomass crops. And among the two woody crops, willow had the highest amount rather than the poplar. It was about 12 megagram per hectare more than poplar, but we couldn't see difference between two herbaceous crops, miscanthus and switchgrass. They were the same. And comparing woody and herbaceous, in average, woody crops had the higher amount of carbon pools in biomass significantly. It was 197 in woody, the total carbon pools, and 84 in herbaceous. And the last part of the results was system-level carbon gain over the 9 years. So we quantified system-level carbon gain using this equation. We added the amount of soil organic carbon gain plus the amount of carbon in roots, plus the amount of carbon in annual leaf litter, plus the amount of carbon in fine roots. And for roots, leaves, and fine roots, we consider the composition coefficient to convert the amount of carbon that we have in these components to the real carbon that we're going to add to the soil pool. So the results showed that system-level carbon gain is varying between almost 10 in miscanthus as a minimum and to 15 in the willow as the highest one, as a maximum. And at the system level, over the 9 years, the difference between woody and herbaceous was only 1.35 megagram carbon per hectare. So it suggests that the influence of woody and herbaceous biomass crops at the system level carbon gain were similar. In the annual basis, woody crops have a gain of 1.48 megagram carbon per hectare per year. And this value for herbaceous was 1.31 milligram carbon per hectare per year. In conclusion, looking at the big picture story, as Sudan said, we have kind of 10 million hectare marginal land not suitable for agricultural production in Canada, 1 million hectare in Ontario. Considering the average of system level carbon gain, that is 1.4 milligram per hectare per year, if all the available marginal lands are completely utilized, the potential carbon sequestration would be something like 50 million megagrams CO2 equivalent per year for whole Canada. That is about 7% of total annual Canadian greenhouse gases emission. This value for Ontario is 5 million. So this suggests that woody and herbaceous both in Canada's marginal lands can positively contribute to climate change mitigation efforts. So in addition to this carbon sequestration, ease of adoption, market demand, and other use of biomass like animal beds, animal feed, and bedding can also influence the growers to decide which kind of these two biomass crops should be considered. So I would like to thank you all my colleagues and students that helped me on this experiment, and also the organizations that financially support OBPC, OMAFRA, Best in Science, and University of Guelph, and thank you for listening this presentation.
I'm wondering about, we mentioned 3-year harvest cycles, and is it every 10 years that there's a replant, or what's the replant period?
Or woody?
Yeah,
Yes.
or both.
Woody is about 21 years. We can take 7 harvests of 3-year interval.
Okay.
So 21 years we can replant. You have to replant.
And I guess what I'm wondering is, do we have any idea of the carbon loss in that replanting? Is there any carbon loss in that replanting period?
Yeah. We will not expect, because all the willow roots, the stumps,
Yeah.
are going to be incorporated into the soil.
Yeah,
So there will be a loss. I'm not saying no.
yeah,
But I'm thinking the mass of organic input will be higher than the losses. So we might have more gain in the soil rather than the losses, because if you take into the root mass. So you remember that these densities of willows and poplars that Amir spoke are 15,000 stems per hectare. So we have 15,000 stools that will go incorporate when you do the replanting. And then if you look at the carbon, willow ground carbon was per hectare was how much? It was. Now these carbon values, so this is a very interesting work, and this work was published in the Journal of Sustainability, which is a high impact international journal. What we did here was we gave the answer, the J-cast. Like we looked at the system level gain, above ground, below ground, and included the losses of decomposition. So this is a net gain that we reported on an annual basis. So this is what we need for carbon credit purposes. So we looked into the losses. So all the decomposition coefficient that Amir showed are the losses associated with decomposing, continuous decomposition of fine roots and everything. But interesting, James, what we found was even at 15,000 stems, where the below ground carbon in switchgrass and woody did not change. There was no difference associated with the biomass.
I really like your
Yeah, so
the acreage.
yeah, for the system level, we saw that losses through the decomposition. So we have the separated decomposition coefficient for each components. Yeah.
So that 10 million hectares you said of marginal land, what's it doing now?
Abandoned.
Abandoned, it's not being pastured or like it's not growing forward?
Well, there's grass and some pasture there, but it's generally considered as a marginal abandoned land. He did a nice work, the Liu Itel, I think, right? Liu, right?
Yes.
Yeah, he did a nice work of identifying those lands on different limitations.
Yeah, this is Leo 2017.
Yeah. So that's the distribution across Canada.
So this year's potential Canada is 50 million tons per year sequestering, and do we see it plateauing at the capacity of blah blah before we have diamonds down below? So how many years can we go of, and does it start to flatten off at what level?
No, this is annual contribution, so at 7%.
Yeah.
And then switchgrass, how many years you keep the switchgrass? 10 years, 12 years?
10 years.
And then you replant. So,
Sorry, that's what we can put into the ground.
yeah.
Capacity of the ground to hold is going to be plateauing out at what level, how many years?
Yeah, that's what that's that Southernist presentation we did. We don't know like how much it was going to gain and flatten out. That will depend on the adjacent woodlot carbon. That's why we are assuming that it will reach to the soil carbon levels under the woodlot.
So 50-50 gets to 170 in 3 years?
Um,
No, I'm mentioning the numbers, but I'm just...
yeah, well, it can take long. I mean, we've seen changes in 10 years, 11 years. So, and then to reach that level of woodlot carbon, but remember we have messed up for 150 years for it to reduce. So even 150 years, it might take. Oh, a good question, because we also published another paper. I don't think we presented that data on land. We modeled this gain. Based on this study it did, we modeled the gain. So the model is for 100 years. And what model is suggesting is that, yes, if you keep the switchgrass for 100 years, continuous cropping, there is going to be a gain. But if you convert the switchgrass to agricultural productivity, as most of the landowners do, then there is again a slow declining of carbon will take place. Yeah, that's the land paper. And I think I sent the paper to James and Norm. Those papers should be on the OBPC website. But I think you all were revising your website, and then Norm said after the revision you will put it up. I don't know whether it's there or not, but we can send it again. Yeah, we have got three good publications out of all this work, so we will put it on the website here.
Back to what I was saying about the thin layer of carbon and it getting burned off quickly. A neighbor I had in Chatham talks about land back 50, 70 years ago when they were converting it. They were burning off the marshy land that was at the back of the land I had, and they said it smoldered for about 3 or 4 years.
I know.
So it was, the smoke was still rising out of the land, so it was burning down into it, but over 3 or 4 years.
Yeah.
So that sequestration is not permanent.
Yeah.
It's just-
No, obviously.
And hope we don't get our tundra melt away and reconvert and process that.
And sir, I'm sad to say, like all this data that we got is going to be null and void when the bulldozers come and plow that field up. It's all going to go up in the atmosphere again. So this is the dilemma we are in.
So, when you mentioned like 1 million hectares of undisturbed pasture, is it like pasture land, something like that will be there, or?
The paper is there. The paper is just classifying class 3, class 4 marginal lands. The paper is not saying prairie lands or pasture land or meadows or anything. What the paper is saying is this is marginal, class 3, class 4 land which are not under crop production. That's all the paper says.
Suppose if you assume it as undisturbed pasture land, so how do we compare that carbon with this?
No, that's a good question, Mahendra. So what we have to do is we have to, like the woodlot, we have to keep an undisturbed pasture land undisturbed, and we have to set up these biomass trials and compare to the undisturbed systems to see whether the biomass crops are going to enhance soil carbon sequestration or are they going to be same as the undisturbed systems. But any system that is disturbed is going to be a loss in the initial 3-4 years, and then you'll get a steady gain after that.
To build on that question, like those, as I look there, kind of the blue lands in Ontario, sort of across whatever, Peterborough and whatever.
Yeah.
Like those lands are being, there's hay coming off there or whatever.
Yeah.
There's some agricultural activity. There's not a lot of truly abandoned land.
Yeah.
And so in this case, you built off corn, beans, wheat land at turfgrass here. But I guess the question would be, when you compare it to that sort of underutilized agricultural land that has perennial grasses on it now, would you anticipate the the benefit or the advantage would be the same compared to that perennial, fallow hay once a year, maybe I take something off of it.
Okay, to answer that question, I would go to those areas and identify woodlots. Because, see, our reference point has to be from where we started and where we are. So, if the woodlot carbons are higher than the current meadowland or perennial grasslands, then there's a carbon loss. I mean, if you take any agriculture publication over the 50 years, even in Ontario, there's a significant drop of soil organic carbon being reported in Soil Science Journal, and our expert is here, Dr. Gillespie is here. Once we take the reference point, then we can decide is this land can be brought under perennial crop or just leave it, because they are very close to the natural system, so just leave it.
We just take that one step further, and so this is great work again, but it only gives us a high-level picture of potential.
Yeah.
For instance, if we go to Peterborough, is it going to be willow that's on top again? We're going to have a different soil type, a different weather crop. Like, it may not be the right answer for that particular area. There's going to have to be a lot more work and more specific work done to actually realize those values in the real world. This is indicating, though, that there is a pathway with a reasonable potential, is the way I would sum it up.
Yeah, there's a pathway. And also, lately I was thinking, like, irrespective of the ruling party in Canada, the national security, whether the red comes or blue comes, they don't touch the national security aspect, because that is the benefit for the Canada. And the environment should be added to those national security policies. So whether the red party comes or the blue party comes, they should not be undoing what the other previous government did. Because no government can go and do the national security aspect, because they say there's a no-go zone, because that is the national security for Canada. And environment should be in that category. Now we saw that down south, like all what Obama did, Trump came and undid. And he gave a license for the coal mining and everything. So if that is going to go, like, this research is not going to go anywhere. And so this is what, James is right, this is all complex. So, if a Trudeau government is doing pro-environmental process, whether any party comes after that, they should not be going and undoing what he did. So this is what, and also incentives for biomass or bioenergy, green energy. And if the green energy incentives are high, and if you can make pellets out of miscanthus and switchgrasses, and if they can sell it to $200 a ton, miscanthus acres and switchgrass acres are going to be on the rise. And then if that policy comes, if 3 years later some government comes and discontinues the policy, then we are back to square one.
I actually have a comment, and I think maybe it would be great to get everyone's comment on this as well. So Naraj's team, your work is on soil organic carbon, and my work is on soil inorganic carbon. And one of the questions that I have is, what does it take for the government to say, hey, you give me this data, I'm going to credit your CO2?
Yeah.
Like, what is that magic data that they're looking for? And we have been working for years on to try to do field work, do lab work, to do consolidation of data and everything. To which point are we saying that this is enough of proof that let's just actually promote this methodology or promote this technology? So what is this turning point?
Mm-hmm. Yeah, absolutely. I fully agree. This is and also, how can landowners comfortably retire some of these lands for ecosystem services and still not lose money because they are doing that. So this is where the catch comes, and some governments are doing that. Like Norway just paid, I not fully agree, 150 million euros to Gabon for avoided carbon emissions. Gabon said, hey, if you pay us, we will keep the forest. And if you don't pay us, we have no choice. We have to destroy the forest for resources, and So Norway said, okay, for our emissions, they signed so many $1 million, but the first payment was 150 million euros for Gabon to keep their forest as avoided emission so that Norway can have meat. And these things are happening, and we should come up with something like that. Interestingly, so United Nations, UNESCO, looked at that and they contacted me. They have 171 biospheres across the world, and hope very soon Amir and Mai will be going to Indonesia to assess the carbon in Indonesia and their biosphere. And UNESCO is telling, hey, now we want you to assess this carbon and tell us what is the avoided emission to keep this carbon in the biosphere, in the UN biosphere, 171 them. Just they asking to do one. So they can go to these countries like Norway and say, if you pay so many $1 million to the UNESCO programs, maintaining those biosphere, and the community, all communities are supported, there's people living in those biosphere, they are living in harmony with the nature. So UNESCO wants to pay those communities to keep the carbon intact. And then we have collaborating with Carbon Terra, a company in Manitoba, and we are, Amir and myself, we are going to do ground truth carbon, like the system level carbon Amir mentioned, and they are going to fly the drone, and they have algorithms developed to assess the carbon over the canopy. And then we are going to compare the drone carbon compared to the ground truth carbon, and we are going to adjust their algorithm so that it will be very close, within 5% margin to the actual ones. And once we take that, they want us to go to all the biospheres and fly the drone, and then give them the carbon number. So we are just waiting for the contract to come through to do the first phase for them. So there is, Emily, you're absolutely right. There is interest. We have shown data, but what it takes to say, okay, landowners, you do this X amount of dollars will give you. Any more questions? I'm happy that this is going as a discussion. This is great. I'm very happy. And thank you, Amir, for all the work. And then we will, if anybody wants the publication, just email me or Amir, and we will send the data. Southern's work on riparian also got published in Agriculture Ecosystem Environment. So all these work all published in high impact international journals. And very soon, Sarah is going to follow.